training yesterday. She's like, how bad you are.
So, we need to announce this. If you have a table that was issued from here, okay? Because some of you wanted your own periodic tables, and that's fine, okay? But if you have one that we copied off in color for you, okay, please make sure that you write this content in over here. Manganese, it probably only says +2 on your table. You can also have a +3 charge.
No, it says +3.
Is it the table that was issued to you? Okay, well then, just make sure that you have that with them, okay? So, nickel can be +3, okay? Gold can be +1, and copper can be +2. Because on the table that we copied for you, when I look in these element boxes, these charges are missing. But these also can have these oxidation states and or charges. Okay? Make sense?
Yes, sir.
All right.
Okay. Oh, I'm sorry. Get out a book. Grab a book. Yeah. Not that kind of book. You know what I mean.
I'm gonna read it.
Yes. At least one book per table, at least.
Hey, let me finish writing this down, then I'll get a book.
I'm not, yeah, you're fine.
Huh?
You're okay. And turn to page 569. Okay, so we're actually going to start with 9 and 10. We're going to skip these first couple. On that page, there will be a box that says polyatomic ions. Should be in the right-hand corner. I'm going to look at your, because I'm pretty sure. For your purposes, I mean, I would recommend writing these down, but for your purposes, we do not need to know ammonium yet or ever. Yet?
Just not yet.
Not yet. We don't need to know acetate, and we don't need to know chlorate. But the ones below that, we will use. What's something that you see in common with all of those ones that I listed? There's one thing that they have in common. Except for the top one. Top one is different. The very top, ammonium, is different. But what's the other? They have negative charges. Yep. I think, yeah. -1, -2, or a -3 charge. So they're all negatively charged particles. Okay, what color do I want to use? Blue. Nope. Purple. Okay, so we're going to do number 9. First on the board. I just numbered them so I can have space to work on this side and you know which one I'm talking about. So we're going to do number 9 first. Do you want to give it a shot and then we'll do it on the board? I'm a fan of making you struggle and then finding out if you're right and wrong. Uh, 569 for the book.
Right.
Yep. Yep.
Let me literally open the book to that.
We're just doing formula for number 9. Yep. And with all of these today, we're just going to practice our mass calculations. So let's do mass as well. Hydroxide. It's on your chart. Look.
Hydrogen.
Formula, and then calculate the atomic mass as well of number 9. And also today when we're doing mass, let's use up to 2 decimal places.
Can I get a calculator?
Yeah. Happens.
So if I went up to 2 decimal places, would that round up to 41 then?
Oh, no. So I'll talk about, so 40 and then point, which is a decimal point, and then bang, blank.
Yeah.
So that's 2. So 2 after the
Oh.
decimal point.
Okay. Yeah.
That means it's happening.
So I think that's what you do because it's a hydroxide.
Yep.
So, but is there any numbers?
Yeah, think of the charge. What's the
How do
charge?
I know how to do that?
It's the same thing we've been doing. So what's the charge on a hydroxide ion?
0.
A hydroxide ion? -1. Yep. And do the same thing we've been doing. Hydroxide. What's hydroxide? I tell you, it's not hydrogen.
No.
Here, look at pull your book. Right there. Right. See what I'm saying? Picking up what I'm putting down. Do you have a question?
And you wanted us to do the masses?
Yep.
So would it be oxygen and hydrogen together for my atomic mass?
Yeah, so I know what you're saying. So how many, so this is not quite right, I'll tell you that. Think of the charges on these. So it's a -1, right? What's the charge on a calcium?
Positive 2.
+2. So how many OHs are we going to have? 2. Yep. Do the parentheses, right? So we know that those are together. There's 2. And we'll do it on the board. It's good.
Oh yeah, I did it like.
Are we ready? A little more time? No? Yes? Say something? Oh, okay. My bad.
Just writing the equation down here.
Sure. What's up?
Hydroxide is not hydrogen, right?
Nope.
Then how do we know the mass, like what to add?
Okay. What's the mass of oxygen?
Oxygen. 16.
16. What's the mass of hydrogen?
1.
Add them together.
17.
That's 1 hydroxide. How many hydroxides are we going to have?
2.
2. So 117 plus another 17 equals 34. Okay. We good? Everybody at least got an idea of what we think we're doing? Maybe? All right. I'm good with 50-50. Okay, so calcium hydroxide. What do I start with? Calcium. Ca. Let's do charge right away. What's the charge on calcium?
+2.
+2. Now what's a hydroxide? It's a hydrogen and an oxygen. You can find it on your polyatomic chart there. And if, I won't do that. Write these down is what I'll say. Or refer to your book every time. Doesn't matter to me. Just know these. So you say OH.
Yep.
Right? What's the charge on a hydroxide ion? -1. Okay? So how many hydroxide ions do I need? 2, right? We're going to do I'll just do it really quickly. Least common multiple, 1, 2. We don't need that 1 there. We already know it's there. Where did I get negative? Look at your chart. So on your chart, on the left-hand side, it'll say the charge of those ions, right? And so the box that hydroxide falls in is the -1 section. So we know hydroxide is -1. Look at your chart. In the book, 569, right here. We'll be referring to this. So, see, -1, hydroxide, OH. That make sense? Cool. Okay, so we got calcium, hydroxide, and we have 2 of them. Let's do our maths now. So what is the mass of calcium? 2 decimal places, 2.
48.
Point.
Are you going around or not?
Oh, two decimal places. 0.8, yeah, round. 8. Everybody know how I get that?
Yes, sir.
Cool. Yep, so 0.8. That's calcium. Now we need to add our hydroxide. What's oxygen?
15 point, well, it's like basically 16.
Okay, let's.
15.99.
Okay, so it would be 16. Yep. 16
1.01.
plus 1.01. Okay, if I calculated this, would this be right? No, it would not. Why? We have 2 oxygen and 2 hydrogen, right? Because we can see this right here. So whatever way you want to do it, you can just go plus another oxygen plus another hydrogen, or again for those formula people, you can go like this, times 2. So we know that, right, oxygen, hydrogen, 2 of them. PEMDAS, multiplication first, or addition, well, parentheses first, multiplication, addition. So what's my final value? 2.32, 34, 79.1. All right. Oops. Make sense, everybody? What we're doing here?
Wait, so we have to do the decimals every time?
2 decimal places. Yep. Yep.
Oh,
Is my
shoot.
whole sheet wrong then?
No.
I think it's.
I told you yesterday, just round to whole numbers.
74.1, not 74.
Yeah, I
Oh, I'm sorry. That's my bad. Yeah, it would be. It would be.
Well, then my running-
Yeah, it's fine if you just.
What's up?
I got the 74.
That's okay. That's okay. I'm not grading it.
If we didn't round on the sheet, it's wrong.
I told you to just go whole numbers, no decimal places. It's if you're within 2 or 3, that's fine with me. I know what you're doing because when you get to chemistry and we're doing a lot of stoichiometry and that kind of stuff, there'll be very long decimal places where it'll be just like keep on going with numbers, and people will round differently. As long as you're right there, I know what you're doing. Cool?
Yep.
All right, so everybody, we got this. Let's do cobalt 3 nitrate.
What were we doing now, 10?
10.
Radical.
Five different answers.
5 different answers. For what? For the last one?
Yeah.
Why? So 16 plus 16 is 32. plus 1.01 is 33.01, plus 1 is 34.01,
I thought we got like 74.
plus, so 34.02, plus 40 is 37.1. If I did my math right, and I think I did. What's happening? Oh, good. I haven't even looked at it. So we have nitrate is a -1, cobalt 3. Yeah, you're absolutely right. And do the adding thing. Yep. So,
Mine makes sense to everyone besides. Mine makes sense to me and
what?
nobody else.
For this particular one, it will, it's the number behind it will tell you the charge. So, yep. Plus 3. Yep. It's the number behind it. And it's the reverse if we're doing naming. Well, it's the charge that'll tell you the number. Cool.
Oh wait, never mind.
Okay. Yeah, sorry. I wasn't picking up what you're putting down. Trying? Okay. It's on there, isn't it? Oh, yeah, that whole thing. See that whole box? That means that whole box is -1.
No, like it's nitrate, nitrogen, and something else. Oh, nitrogen, not.
See? Yeah.
You're
This
not
chart.
gonna find nitrate on
Oh,
there.
okay.
That's why you have to look on here.
Yeah.
Not really care.
That's the charge that it has. Basically, that shows you what it's charging.
Getting it? No? Why not? Is it hard?
I don't know.
Why don't you know?
I don't know if that's right. I don't think it is.
This one?
Yeah.
What are you doing? The one right there. Nitrate, say. Move closer to you. That helps.
Oh, no.
NO. No, 3 specifically. How we doing over here? Okay. Yeah. Trying, at least. Because I need you to try. That looks right. Yeah. Yep. What's happening?
What's like the combination for these two, like nitrate,
You can find it right.
nitrogen? Oh, I see. Yeah.
Yes, yep. Okay, how are we doing? Are we ready? Are we not ready?
I'm never ready for anything.
Ah. Switch that around. Always ready for everything. Okay, let's do it. So since I'm not getting any pushback for it. Cobalt 3. What do I write down? CO. What's the charge on it? +3. How do I know it's +3?
Those are the Roman numerals.
Tells me right here. +3. What's a nitrate? What's a nitrate? Yes, you do. I know you do. Look at your sheet. Other sheet. There you go. Or book. I'm sorry. What is it? What's nitrate? Yeah, what's the compound? Right. Oh, I know. I know it's nitrate. It is nitrogen and oxygen. How many oxygens is it? It's 3 oxygens. NO3. How do I know that? It says it right on your book. So if you look on your book, you see the word nitrate. It's at the bottom of the -1 section. And if you read right across, it'll say the compound, which is NO3. So what's the charge on a nitrate?
-1.
The charge is -1. You're absolutely right.
Yes, sir. I told you.
Okay, let's finish this out. Folks, back up out here. So, how many cobalt will I have?
3. 1.
Cobalt.
1. 3.
1.
1.
How many?
3.
3. How do we know it's 3? That's right. We'll do our least common multiple. That means there's 3. What is, we'll get rid of that 1, we don't need it. What does this 3 mean? The first one. What does this first 3 mean?
That there's 3.
That it means that there's 3 oxygen. If it's in the parentheses, it's talking about the atom that it's right behind. So you see, this 3 is inside the parentheses. That means it's talking about this oxygen. There's another 3, and it's outside of the parentheses. That means it's talking about the entire thing. Oh, did you? I'm sorry. I glanced at it.
I feel like we understand it and then there's just another step.
I know. That's kind of how learning works, isn't it? There's a term. There's a term in teaching. It's called scaffolding. That's the point. We're supposed to be throwing in harder stuff every time.
So definitely don't become a teacher.
Okay, back up here. So how many total? Let's think about it in math, right? Let's do a math problem. So if I go 2 times 3 in parentheses, it's what? It's 6, right? It's 6. If I put the 2 outside of the parentheses, and then I go 2 plus 3, what does this equal? That means I have to add both of these first, and then I can multiply them. This is an example. I don't know if this helps, but the outside means it does it to everything inside. Whereas if it's inside, it's only talking.
2 different 3s for oxygen when the charge is only 3.
Because there's 3 oxygen and the charge is 3. That tickled.
It's a good question.
That makes
So why do we need 3 oxygens?
What was that?
It's because, simply put, that's because the compound, that's the way the compound is put together. Because there's 3 oxygens for every nitrogen. But we need 3 of them to reach cobalt. It's hard, complicated, confused. All right, that's fine. That's okay. It's where we thrive. Okay, let's just finish it out. We'll regroup later on this kind of stuff. But let's do the mass now. Let's do the mass. Oh, yes, you do. Okay. Let's start with the stuff you do know. Cobalt. Cobalt is 58.69.
Oh shoot, I guess I did it wrong now because
That's okay.
we added this.
Good, that's fine. Doing it wrong's okay. This marker. No, doing it wrong right here is fine. This is where you should get it wrong.
Where'd you get
No.
9 from?
I'm changing markers just because
I
it's.
got 59.
Okay, let me read it. Cobalt. All right.
59.0.
Cobalt is 58.93 on your chart. 2 decimal places. Okay, now we're gonna get to
Don't you round it?
2 decimal places. Right?
What is all this math? So you can push it up to 59.
You know what? I signed up for one math
by rounding
class,
and just
not
round it up to 59. It's just easier that way.
It's easier, but why do we want to do things easier? You get nothing done if you do it easier.
Less confused.
That is some weird advice I've ever
Will,
heard.
okay. Science is math. I know.
I only have 6 math classes.
All right. Enough of this. Okay, let's finish it out. If this makes this problem easier, we'll round it. 59. All right. I'll concede. I'll give you this one time. We're gonna just make it simple. Okay.
I mean, that looks like a. Actually,
And I don't think we're ever going to learn how to do it the right way. 'Cause it's not smart.
Attention up here, please. I'm begging you. Okay. How many nitrates do we have? We have 3 nitrates. Okay? And inside the box, so we have 3 of these. So if I could write it, it's basically saying N, N plus NO3 plus NO3 plus NO3. This is what we're saying. It's the same thing. There's
Multiply by 3 again. And then multiply it all by 3. Whoa.
no, not quite.
Wait, so you don't multiply oxygen? So why do you
What?
have to multiply it by 3 times?
Yes, you are right. I see what you're saying now. So that's what we're doing. Okay, let's go with nitrogen. What's nitrogen? What's the atomic mass of nitrogen? And I said I'd make it easy, so we'll put it 14. Would you rather add all the nitrogens right now or just wait until the next one? Okay. So we have nitrogen. Let's multiply it then. So nitrogen times 3. Oh, gross. I don't like the way I did that. Let's go. 3 nitrogen. We have 3 of them. 3 nitrogen. See how I'm getting that problem? Okay.
I have to multiply by 3 again.
Okay.
So you don't multiply oxygen by 3? Don't you have to multiply both of that by 3?
Okay. Are you ready?
No, you multiply oxygen by 6. What? Hannah!
I'll tell you in a second.
You do not need to be giving
Okay. Let's move on to oxygen now. So we know we have 3 nitrogen.
Where'd you get 6
Those
from?
real numbers.
Oxygen is 16.
Oxygen is 16,
What? Oh, what the frick stuff.
right?
Yes.
Oxygen is 15. Let's round. 60. Oh,
I explained how to get the whip.
so oxygen. So oxygen.
This is the problem that
Yeah.
you have. Just let Mr. Wagner explain this, and you'll be just fine. All right?
Okay. Oxygen, 16, right? Okay. So we have 16. Oh, we don't have 16. Well, no. So 16. We have 3 of them for every single one, every single nitrate we have. So if you think again, we have CO plus NO3 plus NO3 plus NO3. This is just expanded this, right? 3, 1, 2, 3. Cool. So 1 oxygen is 16. What's 3 oxygen? 16 plus 16 plus 16, 32, 48. Right? So 3. We got to multiply 16 times 3. And that's just one of these. That's just one of these. 16 times 3. And then we add another 16 times 3 because we have another one. Or 48. Or, yeah, 48, whatever you want to do. So we have another 48. And then we have another 48. So how many 48s do we have in total? 3. Do we add them together to reach our final? 16 plus 16 times 3 plus 16 times 3. Yes, you could do that. Yep. So 48 plus 48 plus 48 is what? So 96 plus another 8 is 44. 144, if I'm doing that right. Might be 134. Is it 144? Excellent.
144 say it's.
No, that's how many oxygen we have.
I got 860.
Okay, so this is only the oxygen in the compound. This is only the oxygen. So now we have to go back and add it to our final problem. So 3 times 14 is what? 3 times 14 is what? 42. It is. Add them up. Simple math. Add them. Yep. 59, which is our cobalt. 42, which means 3 nitrogen. And 144, which means 9 oxygen. What's our final answer? 245? Okay. A lot of kicking and screaming, but we've got her. We got her answer. Why?
I like even answers. I don't like.
I know, but you'll see decimals a lot in the world. Oh, you guys are. One more? You want to do another one?
No, just say we're gonna have to use them.
I got 860 on this. So what did you call him? I forgot his name.
Mr. Wagner. That's all right. It's okay.
Yeah, I got like 700 something.
I don't know.
Maybe it's because my calculator.
I'm not sure. That's probably it. Yeah, that's it. Definitely the calculator. Okay, I've got a couple more problems for you to do. Now we're going to be talking about covalent bonds. So we're just going to...
No, it definitely wasn't my calculator. That's what I had.
Getting rid of these. So let's do number 1. And we're doing, I'm sorry. We're doing the Bohr models. Not Bohr. Electron dot diagrams. Yep. I'm sorry. Electron dot diagrams is the word I was looking for. One. What? They do. That's a hint. And with these next 3 problems that we're going to do, work them out. You might get them wrong. That's okay. Who cares if you get it wrong? Not me.
We can only use 6 hydrogens.
Only 6 hydrogens. So try stuff. Carbons can connect to each other. Hint. Electron dot diagram for number 1, C2H6.
Girl. 6
Oh,
helium
sorry.
or hydrogen.
Yes. Girl. Yeah, I see what you're doing. You're right. Yep, that's it.
Hydrogen only has one thing.
Yes, it does. Do you have a question? Somebody have a question? Oh, okay. Are we getting close on one? Are people working ahead? That's fine. Me? Yeah, I mean, you're right. That's not like. Okay, kind of right.
What's wrong? What's wrong with it?
Just the way you had done it.
One,
So think of, let's see, Ryder.
I don't think I
Ryder's got the right idea. Just hang tight. Yep. Yeah. Yeah. Okay, let's do this. What should I start with? I think 2 carbons, you say. How many electrons does a carbon have? 4. I'm going to put these together. Did everybody get this?
1 second, I'm gonna erase
I got that.
So, how many openings do we have for an extra electron? How many spots do we have to fit an extra electron in there? We have 6 spots. So how many hydrogens do we have? Oh, that's handy. Tell me what I should do. You think I should write one at each of the different dots?
Yeah, but you have to add his electron.
You do. I don't know. E. Right?
Yep.
Did everybody get that?
I got that.
That's fine if you didn't. That's okay. But this is what we'd call, what kind of bond is this? And I'm not talking about covalent. It is a covalent bond. A single bond. That's exactly what I'm looking for. Keep that in mind. Let's do number 2. Number 2.
Oh, brother. Oh, Lord Almighty.
Keep single bond in mind. It's that word floating around in there. Bouncing around.
Can you combine all of the atoms in the carbon to make it one? Make it one full thing? Like just give carbon 8 and then 6 from the other one?
No,
Like that?
that's not what we're going for. Where are you at? Okay, I see what you're doing.
Do I put carbon or hydrogen?
You don't put any because that's not how you do it. I'm sorry. Oh, you put, okay, I thought this was attached to this.
No.
You put a carbon. Give me a hint. And let me tell you, single bond isn't what we're going for. What's above a single bond? A double bond. Did I say those are due today?
Yeah.
Oh, whoops. I'll pick them up. Actually, yeah. Actually, just hand them to me on your way out. Okay, are we ready? I'm going to do it. So we have 2 carbons. I'm going to start with carbon again. Each one has 4. How many hydrogens? 3. 3 hydrogens. If I do the same thing as last time, will it work? And then have a bromine, and I could stick 1, but then we have 2 openings. That's not going to work. So what do you propose we do? We could start with bromine. Think of single bonds, double bonds, triple bonds. Okay, so what do you think we could do? I'm giving you a hint. What do you think we could do to these carbons? We could make a double bond, right? Bounce this down, bounce this down, and now we have a what? A double bond. And how many more elements or atoms do we have left to use? 4. How many spots do we have to put them? Hey, look at that. That's convenient.
That's pretty neat.
It doesn't matter. Well, for our purposes, it does not matter where you. Well, actually, I should say, not for our purposes. It does not matter where you put the hydrogens or the bromine. They both provide a full orbital for that, or a full set of electrons for that carbon. It'll be R and then box. Right? Or any variation of this. Bromine can go here, here, here. Does not matter. You could even have it up here. Doesn't matter. As long as carbon's got 8, which it does. So 2, 4, 6, 8. This one also has it. 2, 4, 6, 8. And our bromine, with our 7 electrons on the bromine, 2, 4, 6, 8.
Are we done or what?
Done for today. Get out your sheets. I'll take them. Goodbye.